Okay, so question 7 requires you to draw 3 Born-Haber cycles. You're going to have to draw the Born-Haber cycle for copper chloride, the one for copper chloride, the copper 2, sorry, it's not copper, it's cobalt, cobalt 1 chloride, cobalt 2 chloride, and cobalt 3 chloride. And they want you to calculate the enthalpy of formation for all of these. Okay, so let's have a look at how we can do this. So we're going to react cobalt with chlorine, and depending on the chloride we're going to make, down here it would either be cobalt chloride, cobalt 1 chloride, or it's going to be cobalt 2 chloride, which is where we've got CoCl2, or cobalt 3 chloride where we've got CoCl3, and they're all going to be solid. So let's just have a look at cobalt 1 chloride. So cobalt 1 chloride is cobalt's got a plus charge and chlorine has a minus charge. So what are we going to do here? We are going to atomize our cobalt. So the cobalt's going to become a gas. And then what we're going to do is we're just going to take 1 electron off that, and that is going to give us our cobalt ion and an electron. Okay, and this is where it differs then, because if we're making cobalt 2 chloride, we would take another electron off and get the CO2 plus ion. And if we were making cobalt 3 chloride, we would then take another electron off and get CoCl3. So they follow the same pathway. So perhaps you could have a look at that. What I'll do, I'll make CoCl2, and then you look at making CoCl and CoCl3. Okay, so to make CoCl2, cobalt 2 chloride, I need to take another electron off that cobalt. So there we go, taking an electron off, it's still a gas, and there's my 2 electrons. If you're going to make cobalt 3 chloride, as I say, you would need to take another electron off. Let's have a look at the chlorine, what we're going to do with the chlorine. So the chlorine at this point stays as a gas, because I'm not doing anything with it yet, not part of this model. Okay, so now I'm going to look at, I've finished with the cobalt. Now with the chlorine, I'm going to atomize the chlorine. Okay, so if I've got cobalt 1 chloride, then down here this would be a half a chlorine molecule. If I've got cobalt 3 chloride, this would be 1.5 moles of chlorine molecules. But I'm using cobalt 2 chloride, so it's just 1 mole. Oops, I can't see what that is. There's a plus. Right, so I'm going to make chlorine gas atoms, and because it's Cl2, I'm breaking the bonds and I'm making 2 moles of chlorine gas atoms. And then I'm just going to transfer those up, plus 2 electrons. Okay, so the next thing that happens then is that the chlorine atoms are going to pick up the electrons. So I'm going to make 2 moles of chloride ions. And there's the cobalt 2 plus as a gas. And then the final thing that I'm going to do is that those ions are going to come together and they're going to make my cobalt chloride. And this is the formation enthalpy. So if you're doing cobalt 1 chloride, at this point here you would then atomize the chlorine, and then the chlorine would pick up the electrons. If you're doing cobalt 3 chloride, you've got one more step here to make cobalt 3 plus before you then atomize your chlorines. Okay, so then the point that we do is we are going to put the values in. It's this that we want to find. It's this formation data that we want to find. So what is the formation data for cobalt 1 chloride, cobalt 2 chloride, which is what this is, and cobalt 3 chloride? What is that value? So if I do this one, using the information that is given, it says the lattice enthalpy of formation for cobalt 2 is minus 2624. So minus 2624. And then I'll get all the other data from here. Okay, so I'm going to use this, and all the cobalt data is there. So I'm going to put those values onto my cycle now. Okay, so let's see what I've put on. So we're trying to find the formation, enthalpy of formation X. The atomization enthalpy of cobalt is plus 427. The first ionization enthalpy is plus 757. The second ionization enthalpy is plus 1640. And then I've made 2 moles of chlorine atoms, and it's only given me atomization data. So it's 2 times 121, and that, if you haven't realised, is positive. That's positive. And then first energy enthalpy of electron affinity is negative. So, but I've made 2 chloride ions, so it's 2 times minus 364. And then the enthalpy of formation is minus 2624. So how am I going to calculate this? So I'm going to start from here, and this is what I want to find out. So that's x equals, and I'm going to start from the same point, I'm going to go round the cycle, and I'm going to finish at the same point. So I'm going to finish at COCl2. So if I do that, I'm going to go up this way, up that way, and down here. So when we put those numbers in, it's going to be plus 427 plus 757 plus 1640 plus times 2, 242 minus 360, so that's 728 minus 2624. And when we add all of those up, we should get an answer. The answer is minus 286. So the value for this is minus 286 kilojoules per mole. When you work out cobalt 1 chloride, it's positive. I think it's positive 246. It's quite positive. And when you work out cobalt 3 chloride, I think it's minus 25. So cobalt 1 chloride is something like plus 246 or 248. I can't quite remember, but it is quite high. And cobalt 3 chloride is minus 25. So if you can have a go at those and see if you can get those answers.